grade Cougars, Mrs. Belatesh here. And I want to talk a little bit about magnets again before we continue. So last week we talked about two important words. One is attract, and that is when two magnets pull together. And the rule for attracting is opposite poles attract, right? North and south attracts. The other word we talked about was repel, and that means to push away. And the reason that magnets push away or repel is because the same poles repel. North repels north and south repels south. Now, we also noticed that the magnetic force could actually travel through materials. We had the cardboard and the paperclip, and we could, even though the cardboard and the paperclip weren't touching, the magnetic force went through the cardboard. Today, I want to see if there's a way that we can measure the strength of the magnetic force. I have a balance scale here. And we've used a balance scale before. When it's completely balanced, then we know that there's equal weight on both sides, right? I'm going to use it a little differently this time. Instead of looking at how heavy in balancing it, I want to see the strength of a magnetic field. So what I have done is I put a magnet on a little post, and on this balance there is a hole, and I can put the magnet right there. Now, boys and girls, I don't have a balance scale for every student, and as a result, you're going to have to just watch this experiment, and I apologize about that. So I've got my magnet here, and what I'm going to do is I'm going to put another magnet on top. So you see how these magnets are stuck together? This one is on the post, and this one is in the cup. And I'm going to put it here. And now, if I push down on the other side enough, it will let go. So I want to see how much weight I have to put in on this side in order to break the bond between the two magnets. Okay, so boys and girls, I actually got a different post because the other one was falling out, the wood one. So I have a post, and it stays nice and stuck in the little hole there. Okay, so now I'm going to put a cup on the other side, and right now I just have the cup in between the two magnets. So it's magnet, plastic cup, magnet. And I'm going to put these gram pieces. This is a 20-gram piece. I'm going to put 20 grams in, 160, 180. Okay, 180, it falls apart. I'm going to take 20 out. There we go. So let's count up how many gram pieces there were in there that broke the force. 20, 40, 60, 80, 100, 20, 40, 50, 1, 2, 3, 4, and on the fifth one, it fell. Okay, so now what I'm going to do is I'm going to use this little yellow disc, and I'm going to put it on top of this magnet. And that is going to increase the distance between the two magnets by just a little bit, by just the thickness of this plastic chip. And now I'm going to do the experiment again, and I'm going to see if there's a change in the number of grams that this will hold before it falls. So here we go. 20. Whoops, there we go. Let's count how many grams it held before it broke the force. So we've got 20, 40, 60, 80, 100, 20, 35. And at 135, that's where I'm going to add another spacer. So now I'm going to have 2 spacers in between. So I'm going to have the magnet, 2 spacers, and then the other magnet. All right, now I'm going to put the cup in. Before I begin, does anybody have a prediction? How many grams do you think that this will hold now that it has 2 spacers? Let's find out. 20. Okay, so let's count how many this is. 20, 40, 60, 80, 90, 5, 6, and 7. 97 grams. All right, here's the next one. This has got 3 spacers this time. 20, there we go, 74 grams. We're gonna do one last one. I'm gonna put 4 spacers in between. 4 spacers and see what happens. Can you guys please make a prediction about what you think is gonna happen? Okay, I'm gonna add the cup and some gram pieces. 20, 57, I think. I'm gonna count them, make sure. 20, 40, 50, 1, 2, 3, 4, 5, 6, 7, 8. So it held 58 grams. This is the result of our experiment. 0 spacers, the magnetic field was strong enough to hold 154 grams. And all of the data is recorded here. And this is pretty good, but sometimes making a graph really helps to make a prediction for future actions. So I want to take a look at a graph and a curve. Okay, so I made a chart, and on the vertical axis are the number of grams that I used to break the magnetic force. And on the bottom are the number of spacers, or those little discs that I used to break the force, to separate the magnets. And I charted where each one of those dots were. The great thing about a graph like this is that you can make a prediction, right? So we know that it started out at 155 grams with no spacers. With 1 spacer, it went down to 134 or 135, and then it went down to like 97, and then it went down to about 68, and then it kept going down. That was with 4 spacers. Based on this curve, we can make a prediction about what the strength of the magnet would be with 5 spacers, 6 spacers, 7 spacers, and on. Boys and girls, please get out your science journal, and you're going to glue this page into it. Magnetic force graph, okay? And I'm gonna go back and put it into my table of contents. So I'm gonna go to the front, and I'm on page, oh, I didn't put a page number on it. 11, I'm on page 12. Your page number might be different. And it's called the magnetic force graph. So put this into your table of contents. And I'm gonna put my page number. All right, so you've got it glued into your notebook. You've got the date at the top, and you've got the page number. All right, now let's take a look at this graph. You're going to need to put some information on the axes. So on the vertical axes, this is the number of grams. Now on my board, I had used 5s, but we're going to use 10s because we don't have enough space. So you're gonna put 10, 20, 30, 40, all the way up to 160 or more if you want. And at the bottom, it's going to be the number of spacers. So you put 1, 2, 3, 4, and the first line means 0 spacers. There's no spacers there. okay? And now we're going to record our information. So the very first one, it was 154 grams, right? So you're going to put it on this axis, directly on this axis, and because we're at using tens, basically it's going to look like 155. So you're going to put a dot there. And then for the next one, you're going to put a dot, all of that data that I had presented before, you're going to graph it on this. And then you're going to connect the dots, right? You're going to connect it so that it looks like a slope, so you can make a prediction. All right. Now, then there is a question that I want us to answer. And the question is, and I want you to write this in your notebook, what happens to the magnetic force as the distance between the magnets increases? So my answer is the magnetic force decreases the farther the magnets are from each other. We know this because, and now boys and girls, I want you to make sure that you say why we know this, right? We can't just say, well, this is the answer. We need to give evidence, okay? After you've done that, remember, you need to add one more question to your notebook, something that you still want to know about magnets or electricity, something about what we've been studying. All right? I'll see you next week, Cougars.